A skydiver jumps out of an airplane at 11,000 feet. While she's in free fall, her altitude in feet t seconds after jumping is given by this equation. So this is our equation. We know it's going to be a parabola that opens downwards, and we know that because of the negative leading coefficients. So parabola opening downwards, that's how much we know. Part A says, make a table of values showing the skydiver's altitude at 5-second intervals. So I have to put in time equals 0, and then time equals 5, then 10, then 15, 20, and so forth. And we're going to use the table feature of the calculator to see this. So for part A, I have it done over here. If you can see, time starts or x is at 0, then 5, 10, 15. So using the table feature second table set right here, like we did in class, you can put in a start value of 0 and your delta t will be 5. So these are all the values that we get for the table. So instead of doing it by hand, we can see that at 0 seconds, 11,000 feet up in the air, then 5 seconds later, 10,520, and so forth. And it looks like at 25 seconds later, the skydiver is 600 feet up in the air. And then those negative values don't really mean anything for us. And this is the window I'm using to graph this. Because I see on the table that between 0 and 25 seconds, something interesting happens and the y values or the height keeps going down. I made my x min be 0, my x max be 30, just to cover my bases and go past the 25 seconds. And then I made my y minimum be 0 and my y maximum 12,000, because I know the highest up here is 11,000 where the skydiver starts. So I'm just going to go all the way up to see a little bit more. So there's our window, there's our table, and here's our equation in y equals, and it looks like the graph looks like it is a parabola opening downwards as we had suspected. And the highest, we know the parabola goes, or the vertex starts at 11,000, because that's how high the skydiver was to begin with, and then the skydiver jumps and keeps going down and down and down, and at some point, which we know must be after 25 seconds based on our table, the skydiver is gonna land and hit the ground. So at some point after 25 seconds, it seems like. And this is all my height. Now let's go back up. So we looked at part A. Part B, we have graph the equation, so we did that using our TI and the table feature. Part C says if the skydiver must open her parachute at an altitude of 1,000 feet, how long can she free fall? So for part C, we know the height is 1,000 feet. We want to know for how long she can free fall, so we're interested in the time that it's going to take the skydiver to get up to 1,000 feet. So let's say 1,000 feet is there. The skydiver's coming down, coming down, coming down, and 1,000 feet is, let's say, right there. This is the time we're looking for. Again, we can try to look at that on our table, but I don't see 1,000 feet on my table, though I can use my TI to find it. I'm going to go ahead and do it algebraically up here. So let's go plug in 1,000 for the height, and then solve that quadratic equation. So I'm going to subtract 1,000 from both sides to get it equal to 0. Now I don't like the negative leading coefficient, and I know they're all divisible by 16, so I'm just going to divide everybody by a negative 16. Remember, every single item has to be divided by the same number. Left side still stays as 0. I get a positive t squared, a positive t, and positive divided by a negative is a negative 625. So instead of spending time and trying to factor this, since the number is sort of big, I'm going to say a is equal to 1, b is equal to 1, and c is equal to negative 625, and use the quadratic formula. So t will equal to negative b plus or minus b squared minus 4, a is 1, and c is negative 625. All over 2a, and a is 1 anyway. So multiplying these out, I get 2500, and then this is going to be a positive, so 1 plus 2500, it is 2501. And I'm going to go ahead and approximate what this square root is going to pop out. And then I'll have -1 plus it and -1 minus it. And again, I'm only going to worry about the one that gives me a positive value. This one looks like it's going to give me a negative value. So forget that, because it's going to be a negative value for time and I don't need it. So it looks like we get 49.01, let's say, divided by 2, which gives me 24.5 seconds for my time. So basically after 24.5 seconds, the altitude is 1,000 feet for the skydiver. So let's see what will happen graphically. We were to begin with at 11,000, and then at about 1,000, let's say right there, I'm just going to guess, ballpark it. How long has gone by? 24.5 seconds. So let's say that's 1,000. This would have been at 24.5 seconds that occurred. So if I try to be a little bit more accurate actually and count the x coordinate or the t coordinate, 24.5 occurs right around there, 24.5 seconds, and 1,000 feet would be somewhere around over here, I guess. So for all this time, for the 24.5 seconds, the skydiver is falling down in such a manner. So part C, we're good to go. We used the equation, we solved it by setting it equal to 1,000. Now part D was a little bit confusing. That one was the one that was causing trouble. It says if the skydiver drops a marker just before she opens her parachute, how long will it take the marker to hit the ground? And this piece of information should have still been on your online homework, which I believe it isn't. It's assuming that once the marker gets dropped, that marker is gonna drop the way this equation behaves. So let's go look at part D. It's basically saying, here's where our skydiver opened the chute. If something gets dropped at this moment, how long will it take that thing to drop and hit the ground? In other words, if that marker travels the same path as the equation they gave us, basically what happened right there, how much time it took from this red dot to go and hit the ground. The marker will have hit the ground right here. Because what happens is when the skydiver at 1,000 feet opens the chute, well, the skydiver is probably going to kind of get picked up again, and then the skydiver will, slowly float down. It's not going to travel the path that they gave us with the equation. They're saying assume that the marker travels the path of the equation, so from here to here, the marker is really traveling. In other words, we're supposed to figure out what the x-intercept is or the t-intercept is, and then look at that time difference that it took the marker to go this path. So it looks like it's a short period of time from 24.5 seconds to something maybe past 25 seconds, because I know at 25 seconds, in that other half a second, the marker is already down another 400 feet. So let's go figure out what this t-intercept or the x-intercept might be to be able to answer part D. So for part D, we have h equals 0 because now the marker hits the ground, so height is equal to 0. And this was our original equation, the way the path traveled. I divided everybody by -16 again. Again, I put it equal to 0 because the height was 0. And now I have this quadratic equation to solve. And I'll go ahead and use the quadratic formula again. I actually had that wrong. I fixed it. I have to divide 11,000 by -16. And this is going to be our C value. So A is 1. B is still 1. C has changed to -687.5. So once I plug it into the quadratic formula for my A, B, and C values, I simplify the square root using my calculator. One of them is going to be a negative answer. the one that's -1 plus the square root of this over 2 is going to give me 25.7 seconds. So basically what happened, if we go back to our graph, at 24.5 seconds the marker was thrown, because that's when the skydiver was at 1,000 feet, and then 27 or 25.7 seconds exactly, if we just round, is going to come, the marker is going to come and hit the ground. So what happened, what is that time difference? We basically take 27.7 seconds minus the 24.5 seconds we had, and we get 1.2 seconds the marker travels, and then it hits the ground. So again, basically what happened, let's reiterate. The skydiver jumped and is in free fall traveling this path, and time goes on and on and on and on, and that happens for 24.5 seconds. So for all that time the skydiver is free falling. And then exactly at 1,000 feet the skydiver opens the chute, so the skydiver probably gets sort of pulled up with the chute and then starts floating. And when that happens, right before the skydiver drops a marker at this instant, so the marker travels this path right here, and that time we've just figured out was the difference between the t-intercept 27.5 and when the marker was dropped, which is 24.5, for a difference of 1.2 seconds. Now let's go up, make sure we answered everything. We answer that. How long will it take the marker to hit the ground? 1.2 seconds later it hits the ground. Find points on your graph that correspond to your answers to parts C and D. So we have that already. If I go back to my graph, here is my point. Right here is, how long was it? 24.5 seconds and 1,000 feet. And here is my answer to part D, which is 24. Let's get rid of the skydiver, shall we? 27.5 seconds, 0 is when the marker hits the ground. So those are the ordered pairs that correspond to parts C and D. And that's it.